Alright. Okay, hey, here's our first bit of notes today. We have to finish up the half angles. Okay, you need to have these half angle formulas written on your piece of paper. We did the first three yesterday. We're going to finish up the remaining parts that I said we're going to add to it today. Here's your half angle formulas if you don't have them already. Okay, hey, first one, cosine and sine. The most commonly missed question is this one. Is the sine half angle? Because when you look at it, inside the formula there's a cosine written in. I know that really messes with people. All the half angles have cosine in them, so you just have to remember that. The second one is cosine. This one has cosine in it as well. The only difference, it has a plus sign. I don't know why, but this really messes with people, those two in particular. Because they think it should be the other way around. Okay? Or there should be a sign on the top one. But that's it. The third one that we have is tangent. Alright, now this is the formula that the book uses for tangent. That's what every textbook has. This is not the one that I personally use when I do the half angle formula for tangent. There's other ones, and we're about to show you what they are, and then we're going to do a couple examples today. My goal today is to do about 3 examples of your homework, so you know exactly the style of problem that you're going to be working on, and then you know how to accomplish it, you know how to work on it, you know what answers I'm looking for, and then once I'm through my main 3, then I'll give you time where you can actually work today. This assignment I'm going to give you today is going to be due on, let's see, it's Thursday today, it'll be due Tuesday next week. Tuesday. I know it seems like a long time, but trust me, you will want time to work on it. Alright. Okay, hey, on this bottom one, you need to make room on your property sheet. There is going to be 2 more that come after it. Tangent actually has 3 different ones. But here's what I'd like you to have in your notes right now. I'm going to show you how they came up with the second one. Or, I guess, the second out of the 3, I should say. Here we go. Tangent theta equals Alright, I'm going to let you write that down. Yes, there is 2 thetas in there. This is going to eventually mold into my half angle formula for tangent, and this is the one that I actually use when I actually do my homework.
Do we write this on our property sheet or no?
This? No, not this one. We're going to mold it, so this one should be in our notes, and then I'll tell you what I want you to write down. Okay, hey, does everyone have it written down?
Oh man, I'm working on it.
Thank you. Okay, alright. Now, I know that we want to get to the second formula. I'm going to show you how they took this problem and it molds into the formula that we actually need. Because right now, do you agree that there's no half angles written in there?
I think there might be.
There's no alphas over 2s or anything like that? So, we're going to eventually get there. Here's how it works. I want to show you that this right side, this is the more complicated side, actually equals tangent. I want to show that this works. So I'm doing kind of like a mini style problem that we did in the last section, which was 594 stuff, and we did kind of like, you had to prove the right and left sides were equal. You just did a little bit of work. I'm gonna show that right now by doing some basic steps and show you that it is tangent. Then I'm gonna show you what the actual half angle formula is, because it's actually based on this. All right, first, on your paper, or in your notes, I should say. Bless you, whoever sneezes. All right, hey, on your paper, your property sheet, the cheat sheet, I want to know what is cosine 2 theta. That's a double angle. What is the double angle formula for cosine on your property sheet? I want the one that has sine squared in it. So cosine 2 theta, it's a double angle. What is that on your property sheet? The one
Cosine squared theta minus sine squared theta.
what's another one? Is that, I agree with that one.
1 minus 2.
Alright, that's the one I want. 1 minus 2 sine squared theta. Okay, hey, does everyone understand? I just took out cosine 2 theta, replaced it with the double angle formula that's on your property sheet. Okay? The second part here, sine of 2 theta, that's a double angle formula. I think sine only has one formula for it. I believe it's 2 sine of theta cosine theta. That's the property on your property sheet, that's the double angle formula for sine. All I'm going to do is simplify this problem down to show you that it does make tangent. So if I actually distribute the negative sign to the actual parenthesis, what I have is 1 minus 1 plus 2 sine squared theta. So I distributed the negative sign through the parenthesis. On the bottom I have 2 sine theta cosine theta. The ones cancel out. The ones most definitely cancel out here, so I'm left with 2 sine squared on the top over 2 sine theta cosine theta. And what cancels out now? What cancels now at this point?
Theta.
Not theta. Twos are gone. And
Can't read the rest.
one of the sines. And what I'm left with, if I cancel those out, because there was 2 sines top and bottom, what I'm left with is this. I'm left with a sine on the top and a cosine on the bottom, and that is tangent. Sine over cosine is tangent according to your property sheet. Now, why did I show you this? This proof actually is the reason why they have other formulas for tangent. This problem was actually found in their last chapter. It was in the last section, I should say, where you're doing all your proofs, you're trying to show the right and left sides are equal. This is one of the problems. This problem, in fact, is so important because it actually shows why tangents equal to this, and it shows why your half angle formulas is very specific. Okay? Alright, so here's what I want to do. I want to show you what the half angle formula for tangent is using that part I had written in black. But does everyone have this problem written down though?
Yes.
Okay, I'm going to erase the part here. I'm going to show you why this makes the half angle formula. Hopefully everyone has it though?
Yeah, we're good.
Okay, here we go. Alright, hey. Okay, first, I'm going to replace theta with alpha over 2. So I'm going to cut that in half. So theta was some angle cut in half. Now, when I do that, I have to replace all the other parts in the actual formula with alphas over 2's. So 1 minus cosine of 2 alpha over 2's. And sine is 2 times alpha over 2. Okay, we're good?
Yep.
So I replaced all the thetas with alphas over 2's, and what happens here is that it will give me my tangent half angle formula, which is this. It's tangent alpha over 2, and on the other side, the 2's here cancel because I'm multiplying these together, and I'm left with the formula for my half angle. This is one of your formulas you have for the half angles. So this is one of the extra ones you need to add on. This is actually the formula that I use when I do half angles for tangent. I don't know why, it's just the go-to version that I use.
What do I have to write?
That bottom one. That bottom one,
Right side or the whole thing?
this part right here,
Okay.
that part is the half angle formula for tangent. That's the one that I actually use. Now there is a third one. As I said, tangent does have 3 of them, but that's the one that I personally use in my homework when I do it.
You do
You
what?
do
Because
homework?
I do the homework problems with you guys all the time. I always
Why?
do. Because I have to see what the answers are and make sure you know what you're doing.
Why don't you just look in the back of the
Now,
book?
because mine doesn't have all the
Yours it
I thought
does.
your book had every answer.
Mine has the same problem that you guys have where it says answers may vary.
I thought yours in your, on the pages it had.
On stuff like this, it won't. It'll say answers may vary.
Why?
Because there's different formulas.
That's weird.
So,
You should
alright.
get your book.
The other formula, this is the other one that I'd like you to have written down. It's also one of the half angle formulas for tangent. Here it is. It's sine alpha over 1 plus cosine alpha. That's the other one. It's almost a flip, but then there's the plus on the bottom.
So do we want to write that one?
You want to have those as well. These are all three of the half angle formulas for tangent. This is an extra one. It's just one that I can show you how they came up with it, but I'm not worried about it. I use the one in blue. This is the one that I use for my homework when I do it. But those are your three. Those are your three main formulas for tangent. Okay, the goal today, now that you have all three of those written down, again, these you need to add to the bottom of your property sheet if you have not already, the half angles. Goal today, do 3 examples of your homework problems pretty quickly, so you know what you're doing, you know how to attempt them, and then go right into the actual problems that you have for your homework.
I thought you said if we were good, we didn't have homework.
No, I said you will have homework. Depends on how much you're going to get. Whether you're going to get a lot or little.
I'm so confused.
Okay, does everyone have their half angles? I'm going to leave that on the board for right now because that's the one you have to have written down somewhere. I'm going to start with one of these problems because the formula is already on the board. And then we'll get to the second one.
So really, this is just a matter of like finding it on the property sheet, plugging the stuff in.
Exactly
Moving
right.
around.
Exactly right. Okay, here we go. I want to pull a problem from the book here.
What number is this?
Okay, this is a lot like problem number 47 in your textbook. All right. All they're asking for is one specific answer for this problem. They're asking for just what is the half angle formula for sine
7.
for that triangle. No, not 7. All right, here's how it works. You need to know which formula to pick from. Well, obviously, I only have one half angle formula for sine. It's this one. Okay, so this is the formula I'm going to use. So I'm going to throw that over there. So I have plus or minus radical 1 minus cosine of theta all over 2. Right? Because that's the angle that I'm using. That's the formula that I have. And again, how I know it's theta, it's whatever angle's on the top. That's what goes in here. So if your problem uses alpha, you better have an alpha here and an alpha on the inside. And you'd have to find that triangle. Because my triangle has theta. So you'd have to find the triangle that has alpha, because there might be a couple different triangles in the picture. Okay, all I have to do is find the cosine of theta from this triangle. So you have to think about SOHCAHTOA. So this is something you have to have in the back of your mind for today. This will actually be insanely important with the pictures, because they do provide you a lot of pictures today. So I'm going to use SOHCAHTOA, and I'm going to take that number and plug it in here. So, on this one, it's going to be plus or minus, square root, 1 minus, and now I'm going to plug in the number that goes in for cosine. According to theta, what is the cosine of theta? Yeah, 4/5. It's adjacent over the hypotenuse. Hey, stop talking. Now, the last step here, we're going to simplify this problem down. You have to get common denominators on the top, and then we have to simplify it as far as you can. So in this problem, I'm going to need to make the number 1 5/5, so I can actually subtract. That's the number 1. I'm going to subtract straight across on the top, so I get 1/5/2. And then the last step, since I showed you that shortcut yesterday, if you ever have a 3-level, like a 3-tiered complex fraction, Justin, stop talking. So if you ever have a 3-tier complex fraction,
You combine the bottoms.
combine the bottom.
Combine the bottoms.
So the bottom is just going to be 10. Because you can multiply the 5 times 2, and you can just make the 10 there. Because my trick is I always just multiply this number on the bottom, and that's my fraction. Just squeeze them together. Now why that actually works is you're doing a reciprocal, so that's just my little shortcut. You can leave your answer like that. Now I know that technically that's root 1 over root 10, and then you'd have to simplify. I'm not worried about that. I want to see, can you even get the formula set up correctly with the numbers correctly plugged in? Okay, are we comfortable with one of your styled homework problems?
Yeah.
Okay,
We'll go there.
next.
And that was number 47, you said?
That was 47. All right, next one. The next one is a little bit more difficult. Shh. They're going to do a double angle. Now, if they don't give you the triangle right away, you have to go find the actual numbers for it. So here's what I'm talking about. Okay, is everyone good with that problem then?
Yeah. Mr. Warren, I got a quiz for you.
Nope.
All right.
And what number is that? Hey, Mr. Ward, what number is this problem?
Problem around number 11, I think. It's almost number 7. I just changed a negative sign.
This one being confusing.
Okay, this one's definitely more difficult than the other ones. This one you have to draw your own triangle and you got to figure out which quadrant it's in. It's not like the last one they gave me the triangle. You have to go find it. It's in the 3rd quadrant. So I'm in the 3rd quadrant, which is down here. All right, if you're in the 3rd quadrant, it makes sense that sine was negative here. My angle is right against the x-axis, so it always hugs the origin where that's at. But what does sine actually stand for?
Opposite over hypotenuse.
Opposite over hypotenuse. Negative 15, opposite of the angle over its hypotenuse. You'll have to do the Thacker Theorem to figure out the missing wall. So this is, let's call it like x for right now. So we'll go x squared plus negative 15 squared equals 17 squared. This is 225, you square it. This is 289. We subtract this across, and you get 64.
Whoa, is that 8?
And you get 8. So this number is 8. It actually is a negative 8. Now the reason why it's negative, you're in the 3rd quadrant. You're going negative over, negative down. So you have to think about negative signs, because again, when you take the square root to the 64, it's plus or minus. So you really do have to think about if it's positive or negative. Now that I have all the numbers for my triangle, this is the triangle I'm using. I'm just going to do the double angle formula for whatever one they ask for. If they ask for 2 of them, do 2. If they ask for all 3, do 3. If they ask for just 1, in my case 1, you have to find one of them. Okay, so I'm finding cosine of the double angle of theta. So this formula on your problem sheet, if you actually look it up, there's 3 different ones. You can pick whatever one you want. I don't really mind which one you pick. Maybe you're the person who wants to use like cosine squared minus sine squared. Maybe you're the person that wants to use the 1 minus 2 sine, or you want to use 2 cosine squared plus 1. I don't really care which one you pick. Pick one right now.
Sine.
Well, 2 of them have sine. Which one?
1 minus 2 sine squared.
There you go. Okay, 1 minus 2 sine squared. Okay, that's the one I'm going to pick. Okay. Now, if we're doing that, this is what it's literally asking for. Oop. 1 minus 2 times whatever sine is, and you're going to square that number. Here's the beauty of it. We already know what sine is. What was the sine of theta? Negative 15 over 17. I could plug that in, and I can use it. Now, why? Why did I draw the triangle? Because I don't need it, right? I don't need it if I did that. That's why, if you actually choose the right formula, you don't need to draw the picture. I didn't. I already had sine. I can just find the answer really fast. But if you pick the other formulas that we had, I think one of them was cosine squared minus sine squared, you actually have to draw the triangle because you'd have to figure out what cosine is.
That's stupid.
So, yeah, you have to think about the problem before you start it. Now, on this one, you're going to square the 15 over 17, which is 225 over 289. We're going to take it times 2, and then we're going to subtract it from 1. Well, this turns out, if I multiply by 2, that's 450, I should say now. That's 450 over 289, if I multiply by 2. And I'm going to subtract straight across, and that means I have to change this one to be 289 over 289. And I'm going to subtract the 450 over 289. Oh, Jesus.
Negative 161.
Thank you.
Yep.
So we're subtracting those, and then you're absolutely right. The answer was going to be negative, which was negative, say it again,
161.
161 over 289. If I actually subtract. And this number makes sense. The reason why. What quadrant was I in? I was in 3, right? The thing is, theta was in 3, and we were going to double it. So it was going to end up, if I was in 3 and I were to double it, it might end up back in the second quadrant, because it would spin all the way around. I'm going to double it. So it was going to be a big angle, because if you're in that third quadrant, you're in angles like 200, you're in 280, you're in that, that mark where, not 280, but 260, 270-ish area. 260, yeah. You're in that area. Well, when you double it, you can actually end up in the second quadrant, which is what happened here. That's why the answer turned out to be negative. So it's kind of weird that you can actually figure out which quadrant you're in by knowing if it's positive or negative. Okay, questions, comments?
No.
All right, so that's 2 of your 3 problems, 2 out of the 3. The third one that I want to show you today is by far the most difficult. These were easy.
I thought this one was pretty.
Nope.
Get to this one, you said this one's going to be a difficult one. Now you're
It was difficult compared to the first one.
I
What?
can't read the red.
Scoot closer.
This one is going to
I
involve
can't read
knots
anything
and
that
miles
close.
per hour.
Well, then good luck to you.
Every other, I should read everything else. It's just the red color. I want you to write in blue or black or green.
Alright. You still can't see it? You can sit there or there.
I can read everything besides the red.
Yeah.
It's just hard to read. The red glares. Amanda has struggles too.
Scoot closer. So,
Just move closer, guys.
all right, we good?
We are good.
All right, moving on. Last problem. More difficult problem today. This one was definitely harder than the last one, but now we're going to get to the most difficult one.
How much harder is it?
It's on a different level.
What?
It's on a different level.
Like a different level than this one?
Yep.
That sounds muy difícil.
What number is this one going to be like?
It's going to be a lot like problem number 35. All right, here's your last problem. What we want to do is we want to simplify this problem. Now I made it a little bit easier than what they had actually written on number. They had written on number. What is that? 35. I simplified it a little bit because I want to just show you what we can do, and then I'll change the problem up and I'll show you the second style, what they actually asked for.
Which style's easier?
Okay, this one's easier than the one I was about to show you. All right, here's the idea. Your goal is to get rid of anything that has a power that is greater than 1. So you want to reduce the powers.
Same time.
So on this one, if you're going to reduce powers, you have to use the power reducing formula that's on your property sheet. So if you actually look up what sine squared of x is on your property sheet, it was in the upper right corner.
Yep.
It's 1 minus cosine 2 theta all over 2. Correct?
Yep.
Sure, I suppose.
Yep, I see it.
Okay. And so I know it's kind of weird on your property sheet. They put the half out front. It's the same thing. All right. At this point, I don't have anything that has powers anymore. There's nothing with powers in there. And yes, I'm not putting a square on this because sine squared in general means this thing on your property sheet. So I
We
just
just
substitute the
multiply
whole
by
thing in.
3, cut this.
And then you just have to distribute the 6. Well, if I distribute the 6 will divide with the 2 to make 3. So I got rid of the fraction. Right, I got rid of the fraction, then you have to distribute the 3. So 3 minus 3 cosine 2 theta. You want to get rid of anything with powers, you want to get rid of parentheses, all that. Now, why I said that this problem is difficult, because when you look at it, you're like, well, that isn't difficult. It is if I made the power bigger, because the one in the book has a higher power than that. It had a power 4. This is what 35 had. This problem is definitely more difficult because
It looks the same.
this is what we're actually doing.
You have to reduce it twice.
Yeah, you have to reduce it twice.
Oh my god.
So you're going to have to substitute this out, which is the part I just plugged in a little bit ago. But then I have to write 2 of those parentheses, FOIL them together, and then reduce one out of there again. And that's what makes this problem difficult, because if you have 2 of these parentheses, I actually FOIL that all together. So the top turns out to be 1 minus 2 cosine 2 thetas plus cosine squared 2 theta all over 4. If I actually FOIL that all out. And then what I'm going to have to do is substitute out that piece again. So it's like reducing twice. Because I have to get rid of the squares on that problem, and then eventually I have to get rid of the parenthesis that's on that problem. So how I would do it, if I was doing this problem, I would actually make every problem separate. So I would take that problem, that one right there, I would distribute the 6 through the top and divide everything by 4. So 6 over 4 minus 12 cosine 2 theta over 4. And yes, I know those can simplify. And 6 cosine squared 2 theta over 4. So I distributed the 6 through the top, and I divided everything by 4, because that's what that problem is saying. And then what I'll have to do is substitute out this piece, because that one still has a square on it. So if I actually do it, here's what I have so far. And I'm not going to simplify these 12s and 4s at all yet. I'm going to take out that cosine squared, and if you look at your property sheet, cosine squared is 1 plus cosine 2 theta all over 2. Now, the only goofy part is, there was an extra 2 here.
What does that do for us?
That means I have an extra 2 on the inside.
Does that change the problem?
That changes this.
Let's change anything else.
So that makes a 4 theta there.
What is 4 theta?
4 theta is what that thing was when I substituted out. So we won't have to substitute that out, that's no worries. So if I distribute the 6/4 to everything on the top and divide by 2, I have 6 over 8 plus 6 over 8 cosine 4 theta.
That's like the final answer?
This is the final answer.
What?
There is no parentheses, there's no powers that are greater than 1.
You have to do that?
Yep,
That's the answer?
That is a big answer.
that is power reducing. We did an example of that
You
yesterday.
have to do one.
Actually, 2 days ago.
With the 2, with the 4, the
Yep.
4th power?
Yep, 4 theta, not 4th power. So, 4 theta is different than having a
Isn't the one on
cosine.
the right say sine to the 4th?
Yeah, we got rid of it.
Yeah.
That,
so
that
start
from
it
there,
off as
this is
the
what
4th.
it's equal to.
Yeah, so start it off as the 4th power.
Yeah, and then we turn it eventually into that whole thing at the very bottom.
Yeah, that sounds like a challenge.
It is.
I think that one looks simpler.
Okay.
You have to go knots to miles per hour.
All right, here we go.
Knots to miles per hour.
Every conversion for that.
1.15.
Yes, he did. You remembered it. That was my quiz for you earlier. You didn't want me to give it to you.
Here's your homework today. It's due on Tuesday, and don't wait till Monday night.
Should we wait till Monday night before?
Don't. Okay, here you go. Page 614.
So this applies to 9 pin geometry?
4.
What, Sloan?
11.
What, Sloan?
Wait, can you say this out loud?
Just since you don't have a political map value,
Okay.
and you doesn't mean that you have to berate
Can
off
you
for
say no,
having.
no, no, it's really quiet.
15, 2,
Why are you whispering?
56, 57. I'm not going to talk over top of people. So, here's your numbers. 2, 4, 7, 11, 16, 22, and then 36, 38, 41, 43, 50, 52, 56, and 57.
Which one is the hardest?
I believe that the middle problems, I think it's like these are the more challenging ones. These are the ones where you have to power reduce. So you can't have any powers, these will take you a while. Everything else is doing the double angle formula or half angle and just plugging numbers in. So you have to simplify. Okay?
Mr. Ward, I have something to clarify. So we should or should not do this Monday night?
Don't wait till Monday night.
So Monday
But it shouldn't be that bad to sign.
Monday morning.
I mean, how about Tuesday
So,
morning?
we
Start
get
pretty easy, ends pretty easy.
Mark,
But
were we good enough to get the little amount of problems?
that was a little assignment. The big assignment was going to go 2 through 7 all, 11 through 16 all, 22 through 36, 38 through 43, and then 50 through
So we did
57.
good today then, is what
And you can see it on my paper. I had it all
So,
written
Mr.
down.
Ward, you're saying we did admirable today?
Admirable.
Better than most. And that's not saying much.
We did a commendable job per se?